Hello, lovelies. Let's do some organic chemistry. Okay, we are on a line structure. So these are super fun, just lazy ways that organic, you just draw the lines. You're going to put a carbon in each one of these. So there's 1, 2, 3, 4, 5, as if there were carbons here. 1, 2, 3, 4, 5. It's called a line structure. It's very easy. The carbon-carbon bond is always represented by the line. Anywhere a line ends or begins, as well as the vertex, this is a vertex, where two lines meet, represents a carbon atom. Any atom other than a carbon or a hydrogen attached to the carbon must be shown. So you would just put like a chlorine or something right here if that's what you had. Since a neutral carbon atom forms 4 bonds, all bonds not shown for any carbon are understood to be the number of carbon-hydrogen bonds needed. So you can't do anything crazy if you're doing these. Okay, conformations. Conformations. Let me define this for you in red. Conformations. The two-part. Why is it not in red? I clicked red and it's not doing it. Okay, let's try again. The two parts of a molecule joined by a carbon-carbon bond in a non-cyclical structure are free to spin. Seriously. Conformers are actually just conformations, are different. They're conformations of a molecule. Conformations of a given molecule. Okay. Molecule. Okay. Okay, so here's what conformations are. So I have, hey, these super fun things. Okay, see how this guy on the end is free to spin? He's free to spin. This guy is free to spin. This guy is free. They're all free to spin around. This doesn't, they're just conformations of each other. They're just free to spin. What they will likely do is be as far away from each other as possible, but they are free. These little guys on the end, they're free to spin. These guys, free to spin around. So here's one, see, he just spins around like that. And he can spin around with this guy too. He can spin, and this guy can spin. They can all spin. They're conformations. They're not doing anything crazy, they just do that. They just fly all over in space. Those are conformations. The least crowded and the lowest energy is what they're going to usually look like. But it's not thermodynamics. You don't need to know that. Okay. Naming little baby. So you just found this cute little organic molecule and you just don't know what to name it. Should I name it Billy or Joey or Susie or it's so cute? I just want to name it. There are rules. We don't just let you name it anything. You're going to name it something stupid. Like people are naming stupid baby names. Yeah. Okay. So there are rules. The rules are the prefix. The prefix, that's the thing in front. The prefix. The why is it doing that? Oh, because I'm clicking a prefix. It's not red like I want it to be red. Nope, I don't want to do that. I just want it to be red. Stop it. I want it to be red. You see, I will eventually make that red. The word is prefix. Prefix, it comes before. The prefix. This is the location of the functional groups. So that will be how many functional groups there are because you will have memorized the functional groups by then. We'll get to that. Don't worry. Next rule is the parent. This is the big guy. This is like how many. This is going to be your methyl ethyl. This is like the parent. So of these, there's 4. 1, 2, 3, 4. That's the parent. The parent tells how many carbon atoms are present in the longest continuous chain. We're going to talk about that in a minute because that longest chain thing is tricky. And then you have a suffix. This is like naming like royal babies, royal organic babies. This is just like normal names like Billy or Bob. This is like Sir Isaac III. That's how you name organic. You name them like they're royal babies. That's what we're doing. Naming royal organic babies. Okay, here's the super fun little formula. Where are the substituents located? How many carbons are there? What family do the molecules belong to? So 1, 2, diethyl, ether, something like that. That's what we are going to name first is straight chains, alkenes. That's these guys. Just a straight chain, it's not doing anything crazy. You count the number of carbons. Count number of carbons. Then you look at this super handy chart right here in your notes. And you say, how many are there? Okay, I'm going to make that bigger just so we can see it. Okay, there are, let's count our 1, 2, 3, 4. There's 4. So we are going to name our baby Bute. That's a cute little name, isn't it? Number of carbons. So in our case, it's bute. I should make that red, sorry. Butane. So number of carbons is the first thing we're going to do. Then at the end, we're going to add ane because it's an alkane. Number of carbons plus ane, butane. That's our little baby organic name. Don't worry, we're going to do more of these. Do not fret, friends. We will do these over and over again. But those are the rules. Okay. Alkyl groups. These are substituents that branch off the main chain. The main chain. Substituents. Let's spell that correctly. Substituents that branch off the main chain. So in some case you have to figure out, there's the main chain and then what's branching off the main chain. Okay, you have methyl groups. This is CH. Let's do it this way. CH. Oh, you are kidding me right now. CH, pretend that's a subscript. Ethyl is CH2, CH3. So these are the groups. CH, just one. This little guy here, no, he doesn't have enough carbons. This little guy here, this is a methyl group. He's just a little carbon hanging on the end. If there were 2 of them, this guy here, there'd be an ethyl group. Methyl, ethyl. You can keep going if you want with the groups. Those are alkyl groups. They're just hanging off the end of the main chain. Some common alkyl groups. I've given you some. There they are. Methyl, ethyl. You can make isomers out of them because we try and make everything as hard as possible. There's isobutyl, butyl and butyl, and then there's like isobutyl and tertbutyl, and the way they're done. Don't worry, I'm not going to have you memorize those, but you do need to know they're different. So if I give them to you on multiple choice, you can tell them apart. Okay, a primary carbon atom. These are fun. Oh, I went too far. A primary carbon atom. This is an atom with 1 carbon. You should be able to figure this out, but I'm going to do 1 carbon. It's the primary one. So this, a primary carbon atom, just has 1 carbon on it. 1 carbon. A secondary. So this guy has just like, if I pulled them apart, he'd just have 1. This guy, actually, pretend this guy is a secondary carbon. This carbon, a secondary carbon atom is a carbon with 2 carbons attached to it. So here's a carbon, here's 1 carbon, here's 2 carbons. It's got 2 carbons attached to it. Yeah, you see where this is going, right? Tertiary. This is your carbon that we speak of, right? This is your carbon that we are talking about. Here's 1, 2, 3. Now, what could I do? I gotta go deep down into my cavern of organic molecules and get another one. And now, ladies and gentlemen, it is a quaternary carbon. Here's the carbon in the middle, and it's attached to 1, 2, 3, 4 carbons. See how that works? If you just look at it like this, you can see, okay, a tertiary carbon would be attached to 4. 1, 2, 3, 4. So that's how that works. Primary is attached. Secondary is 2 carbons. Tertiary is 3 carbons. 3 carbons. And quaternary is 4 carbons. And we will do this. This is one of those things that just takes a bit of practice. Okay. Now, branch-chained alkenes can be named by following 4 simple steps. 4 simple steps. Name the main chain. So, how are we going to name the main chain? We're going to do back to that chart. Tert, bute, oct. You're going to memorize those little, that little chart. Name the main chain. Find the longest continuous chain. Now, I'm going to mess with you because it sounds so easy to find the longest chain. It's not. Okay. Oh, so let's go back. Okay. What do you think is the longest chain? 1, 2, 3, 4, 5, 6. Wrong. You are wrong. Because it's organic, it has to be harder than that. 1, 2, 3, 4, 5, 6, 7. For real. You could also go 1, 2, 3, 4, 5, 6, 7. It doesn't matter because this is going to be on the second carbon here, the second carbon here, so it would be named the same thing. This, imagine, would spin around. So it's easiest to go 1, 2, 3, 4, 5, 6, 7. And it'll tell you. There it is. Parent hydrocarbon. 7. Now, we're naming it this way because you put the number on what's going to make this the smallest. So instead of naming it, you know, going this way, 1, 2, 3, 4, nope, it's got to be the smallest number. So this is the smallest number. This would make it the smallest number. 1, 2, 3, 4. So it's going to be 1, so it's going to be 2 methyl, 4 ethyl, right? 4 ethyl, 2 methyl heptane. Yep, that's fun. That's a good time. We'll do some of those later. So we named the main chain. Number the carbons in the main chain beginning at the end nearest the first branching point. So you want to make that first one the smallest. Identify the branching substituents and number each according to its point of attachment. Write the name as a single word using hyphens. If 2 or more different substituents groups are present, cite them in alphabetical order. Yeah. If 2 or more identical substances are present, use one of the prefixes as di. So dimethyl. Sometimes you'll have 2 methyl groups or 2 ethyl groups. You'll do like 1, 2 diethyl. Okay. Some fun things about alkanes before we leave. A cycloalkane. So now, now the real fun begins, people. Now we've made now we've made them cycloalkanes. Now it's good times. Now it's good times. Now you get to draw things like little stop signs and little houses and all kinds of fun stuff. A cycloalkane is just a cyclical. It's cyclical. Cyclical. Whoops. It is attached to each other. Cyclical. Or attached in a ring. I should move that over. Okay. Okay. The general form for cyclohexane is CnH2n. So what you're going to notice about this is it doesn't look like a regular. You're going to be like, what is that formula? That's weird. There's not enough hydrogens. Oh, I bet it's a cyclical. That's what you're going to say because you're super smart and you know a lot about chemistry. You're going to say it's missing some hydrogens. It's cyclical. Oh, and then you're going to draw out like one of these guys down here. Yeah, and you also might know that because it's going to say the word cyclohexane. So there's ways to figure that out. One is using this formula and noticing that you don't have the proper number of hydrogens, and that's going to give you some indication. Is there a triple bond? Is there a double bond? Is it cyclical? What's going on? I don't have the right number of hydrogens. And then you're going to draw them like one of these little guys here. Use the cyclohexane name as the parent. So that's like you would put in the parent name. If there's only one substituent on the ring, it's not even necessary to assign the number because it's a ring. Nobody cares. It's a circle. There's no beginning and end. So you just will put like cyclopropane. Identify the number of substituents. Start numbering at the group that has alphabetical priority. Again, alphabetical order. We love it here in chemistry. And proceed around the ring in the direction that gives the second substituent the lowest possible number. So here's our 2 substituents. Like this is 1, so there are 2 methyl groups. So you're not going to go 1, 2, 3, 4, 5. You're not going to go 1, 5. That doesn't make any sense, right? You're going to go 1, 2. So you're going to go 1, 2 dimethyl. You're not going to go 1, 6 and go around the other way. Does that make sense? Okay. That is the end of chapter 12, lovelies. I'll see you for chapter 13 in just a minute. Yay, more organic chemistry. You're going to want to buy some of these for yourself. So